In example 1, we're told each side of the basket shown is an isosceles trapezoid. If angle JML is 130 degrees, so let's put that in. So, oops, need a marker. There we go. So I know this angle is 130 degrees. We know K to N is 6.7. And we know M to N is 3.6. We want to find the measure of angle M to J to K. Want to find this angle here. Well, since we know it's a trapezoid, these are our bases, so we know we got parallel sides. So we have same side interior angles, so that would make that 50 degrees, because 130 plus 50 is 180 degrees. Then we're supposed to find the length from J to L, and we don't have any measurements. But the length from J to L is the same as the length from M to K. So in other words, it's going to be 3.6, not 36, plus 6.7. And that turns out to be 10.3 feet. And there we have it. Now we look at another coordinate plane problem. We're told ABCD has vertices as shown, and I've graphed them for you. We want to show it's a trapezoid. So first we want to show it's a trapezoid. Then we want to figure out if it's isosceles. Well, to see if it's a trapezoid, I think the easiest way is look at the slopes of all four sides. So we'll start here with the slope of AB. Remember, slope is y2 minus y1 over x2 minus x1. So if I look at A and B, so I'm going to say -1 minus 1 over -3 minus 5. -1 minus 1 is -2. -3 minus 5 is -8. We'll simplify that to 1/4. Now let's find the slope of BC. And we'll change colors here so you can see the difference. And so we're going to say 3 minus a -1 over -2 minus 3. Minus a -3. 3 minus a -1 over -2 minus -3. So 3 minus a -1 is 4. -2 plus 3 is 1. So the slope of B to C is 4. Now let's find the slope of C to D. So then we'll say 4 minus 3 over 2 minus a -2. So 4 minus 3 is 1. 2 minus a -2 is 4. So we get 1/4. Notice AB is parallel to CD. And then let's find the slope of DA. So we'll say 4 minus 1 over 2 minus 5. 2 minus 5 is -3, so you get -1. So it's not a parallelogram, so it is a trapezoid. Now, is it isosceles? There's two ways to determine if it's isosceles. Both have to do distance. We can find the distance from B to C, and see if that's the same as the distance from D to A. Or we could find the distance of the diagonals, the distance from C to A, and the distance from B to D. It doesn't matter which one you do. I think we'll do the distance from B to C. Now remember the distance formula, should have written these were all slopes, weren't they? They weren't distance. So the distance formula is x2 minus x1 squared plus y2 minus y1 squared. Let's see if I can fit that in here. I might not be able to. So we're going to go B to C. Whoops, too much there. So we're going to say 3 minus a negative 1 squared. That's the, let's do this like I told you I was going to do. Let's subtract the x's first. So we're going to do negative 2 minus negative 3 squared plus 3 minus a negative 1 squared. Now let's do some simplifying. Negative 2 minus a negative 3, that's negative 2 plus 3, which is 1. So this turns out to be the square root of 1 plus 3 minus 4, or 3 minus a negative 1 is 4 squared. So you get 1 plus 16, which is the square root of 17. Now we'll turn around. We've done the distance from B to C. Let's find the distance from A to D. I'll have to slide back and forth here unless I make this smaller. Maybe let's make it smaller. That's a lot easier. So we want to find the distance from A to D. So we'll say 2 minus 5, the quantity squared, plus, and then we'll go 4 minus 1, the quantity squared. Well, 2 minus 5 is negative 3 squared. 4 minus 1 is positive 3 squared. So we get 9 plus 9, which is the square root of 18, which is not the same as BC, is it? So it's not isosceles. It's just a plain old trapezoid.